welcome back to my YouTube channel in which I have created the playlist of data science covering the basic and advanced concepts. So, my today's topic is logistic regression. Now, let's discuss what is logistic regression. Logistic regression is a powerful and widely used statistical machine learning model primarily employed for classification tasks. Despite its name, logistic regression is used for classification, not regression. It models the relationship between one or more independent variables and a binary dependent variable. It can also handle multi-classes problems with slight modifications. The key difference between logistic regression and linear regression is that logistic regression is used when the target variable is categorical, typically with two classes such as yes or no, spam not spam, default or not default. In data science, logistic regression is a foundational algorithm for binary classification task. It models relationship between input variables and the probability of a particular outcome using the logistic function to output a value between 0 and 1. Now let's see the key concepts of logistic regression modeling. First is binary classification. Logistic regression is used when the outcome variable is binary, meaning it takes only two possible values, typically represented as 0 and 1. The model predicts the probability of an instance belonging to the positive class 1. Second is such central concept of logistic regression is logistic function, also known as sigmoid function. It transforms the output of a linear model into a probability value between 0 and 1. Third is log outs and log it functions. Logistic regression works with or outs, log odds rather than direct probabilities. Log odds refers to the logarithm of the ratio of the probability of the positive class to the probability of negative class. Last, probability and decision boundary. The logistic regression model outputs probabilities that an observation belongs to the positive class. Typically, a threshold, for example 0.5, is set to convert these probabilities into binary predictions. So, now let's see what are the other key concepts of logistic regression modeling. Training the model. The training process involves using the data to estimate the coefficients of the logistic regression equation. Second is optimization algorithms like gradient descent or Newton's method are used to find the coefficients that minimize the error in the predicted probabilities compared to the actual outcomes. Next is overfitting and localization. Overfitting occurs when the model learns the noise in the training data, leading to poor generalization or new data. Regularization techniques like L1 regularization and L2 regularization are used to penalize large coefficients, helping to prevent overfitting by forcing the model to focus on the most important features. Next is multinomial logistic regression, that is also known as extension. While basic logistic regression is used for any collection, multinomial logistic regression is an extension of it that allows for multi-class classification. It is used when the outcome variable has more than two categories. Now let's see what are the advantages and disadvantages. First, cover advantages. It is simple and interpretable. It is probabilistic outcome and it is efficient. Now, what are the disadvantages? First, it assumes linearity. Second is it is sensitive to outliers. Third is limited to binary classification. So let's move to the coding part. Here I have provided the code to perform logistic regression using Python. First, import packages like NumPy, Pandas with aliasing NP, PD, Matplotlib package with aliasing PLT, Seaborn package with alias name CNS, and import required libraries like train test split, standard scalar, logistic regression, accuracy score, confusion matrix, classification report, etc. In order to read in the data in form of iris, I have used load iris method and store the result in iris variable. Then in order to read data in the form of a pandas package data frame, I am using the format pd.dataframe and storing the result in df. In order to target the column, I am using iris target. In order to perform pre-processing, we will first split the data into features and target by using the split function. And then in order to feature scaling standardization, we first use standard scalar method and then fit transform method and then scalar.transform method. In order to build the logistic regression model, we will use logistic regression method and store the result in the model variable. In order to perform model evaluation, we have to first predict on the model, that is through .predict method. In order to calculate the accuracy of a model, we will use accuracy score method and store the result in accuracy variable. In order to create confusion matrix, we will use confusion matrix method, in which we pass y-test and y-prepared variables and store the result in confusion matrix. And at last, we will print the message confusion matrix and store the our result. In order to perform classification report, we will use classification report method, in which we pass y-test, y-prepared parameters, and at last we will show our class report. And then, in order to visualize the confusion matrix using seaborne heat map, first we will use figure method, then we will use heat map method, and we will use title method to show the confusion matrix title. We use X label to show predicted values. We use Y label to show actual values. At last, we use show label to visualize the confusion matrix. So now let's discuss how to perform Poisson regression using Python. First, import NumPy pandas packages with alias name and PPD. Then use matplotlib package with alias name PLD, and Seaborn package with alias name SNS. And then import required libraries like train test bit, standard scaler. And in order to produce random seed for reproduce reproducibility, and we will use random.seed method, which access 42 parameters. And then in order to generate features, we will use random.random method, which will generate 100 data points within the values from between 1 and 10. And then in order to generate the target variable y, I am using lambda function, which is a anonymous function. And then we will use random.random Poisson, in which we pass random method, which we have used above. Now to create data frame, we will use the format pd.dataframe. And in order to perform the preprocessing of the data, we will first split the data into features and target by using split method. And then in order to add a constant, we use add constant method. In order to build the Poisson regression model, we will use GLM method, in which we pass parameters like y train, x train, family equals to dot sm dot families Poisson dot fit method, and then store all the required result in Poisson model. In order to display the summary of our fitted model, we will use Poisson model dot summary function. In order to perform model evaluation, first we need to predict our model with the help of a predict function. In order to calculate the mean absolute error, we will use ABS method and store the result in AMAE. In order to visualize predictions versus actual data, we will use scatter function. Then scatter function, then will x label method will be used to show our studied. Then y label function will show to show events. Then title will be used to show Poisson regression actual versus predicted. And then at last we will show method used to show our predicted method or module. So thanks for understanding or listening me patiently.